So today we're going to talk about mass versus mass number. This is a confusing concept for a lot of chemistry students, and in my last video I kind of glossed over it. We were trying to figure out how many protons, neutrons, and electrons are in an element, and I started with like hydrogen and helium is number 2, so we know that it has 2 protons, 2 electrons, and then we took the mass here and just rounded it off and said 4 minus 2 protons leaves us with 2 neutrons. So we used this to figure out how many neutrons. But if you're paying close attention, some of this doesn't make sense, right? Like, why am I rounding off the mass? Why is this a decimal anyway, right? If a proton is 1 AMU and a neutron is 1 AMU, like here I've built an atom of lithium with 3 protons and 3 neutrons. Look, the mass number is 6. The mass of that number should be 6 AMUs. And if I add 1 more neutron, now the mass is 7 AMUs. Why, when I look at the periodic table, does it say 6.94? Why is there a decimal in the first place? And that's what I'm going to talk about in this video. So you'll notice when I'm building lithium in this simulation that I have to put at least 3 neutrons in there for that nucleus to be stable. But I can put 4 neutrons in there, and it's still stable, and it's still an atom of lithium. So you also might be asking, well, which is it? Are there 4 neutrons in lithium, or are there 3? And the answer is both. And that's where the secret lies between mass and mass number. You see, this is just one atom of lithium, but in real life, when we go out in the world, there's quite a lot of lithium deposits in China, also down in Bolivia. So you can go to lithium mines and you can dig in the dirt, and there's actual lithium down in the dirt. And that's where your batteries come from for your phone. Okay, where's my phone? So in here is a bunch of lithium because we can make batteries out of this metal. Well, some of the atoms of that lithium have 3 neutrons. And some of the atoms of the lithium in there have 4 neutrons. It's a mixture, you see. Okay. What determines that? Well, frankly, that's beyond the scope of this course, and it really doesn't matter to us practical chemists. What does matter is that some of the lithium has 3 neutrons and some of the lithium has 4. The mass of those atoms that have 3 neutrons, those atoms have a mass of 6, a mass number of 6 AMUs. And the atoms with 4 neutrons, they have a mass of 7 AMUs. This mass, 6.94, this is an average. Okay? So what this number comes from is a bunch of chemists, some very smart people, gathered a whole lot of data. They went out into the world to the mines of China and Bolivia, and they dug up a bunch of lithium, and they took a look at it to see, well, how many of the atoms have a mass of 6 and how many of the atoms have a mass of 7, because it's a mixture. And then they took a weighted average of that. So you'll notice that this average is pretty close to 7, and that kind of tells us that most of the lithium atoms in the world have 4 neutrons. Most of the lithium atoms in the world have a mass number of 7. Okay, but some of them only have 3 neutrons, which is a mass number of 6, and that's what brings that average down a little bit lower than 7, down to 6.94. Okay, so I'm going to add this to our notes. So how should we write this? Let's say definition. The mass number is the mass of one atom. We could also say the mass of one isotope. Okay, so one atom or one isotope of an element. The isotopes, that's the different flavors. It's just a fancy word for the different types of lithium, because there's this lithium out there with a mass number of 6 that only has 3 neutrons, but there's also a lot of lithium in the world that has 4 neutrons and a mass number of 7. These are the 2 different isotopes that we see in lithium. Now ptable.com, you might notice right up top, has an isotopes tab, and you can click an element on there and see the most common isotopes in existence. And you will see that lithium actually has a lot of different isotopes. Now only the ones with the black border are stable. And you see there's lithium 6 with the 6 on top, mass number 6, or lithium 7 with the 7 on top. The other lithiums do exist. Lithium 3, lithium 4, lithium 5. They're not stable, they're radioactive. Okay, but they do exist. They go all the way up to lithium 12. So pretty interesting. And you'll notice the mass of an atom of lithium 12 is 12 AMUs, 12.05378. Mass of lithium 7 is 7. Mass of lithium 6 is 6. Okay, so all the lithium in the world is a mixture of many different lithium atoms, and each of those different lithium atoms has a different number of neutrons in it. Those are called the isotopes. So the mass number is the mass of one atom or one isotope of an element. For example, lithium 6, and this is how we write the name of that isotope, has a mass number equal to 6 AMUs. Lithium 7, and this time I'm writing it shorter with just the symbol, has a mass number equal to 7 AMUs. Okay. Now, the mass on the periodic table, the atomic mass, is the weighted average of all the mass numbers of all the isotopes in the world. So, for example, lithium has atomic mass 6.94 AMUs. Okay, it's an average. There is no single atom of lithium with a mass of 6.94. This is the average of all the lithium atoms in the world, the weighted average. Okay, so the last thing I want to note is in the previous video when we were trying to figure out how many neutrons lithium has, what we were really doing is figuring out how many neutrons are in the most common isotope, right? If I look at lithium, that average mass of lithium is pretty close to 7, okay? That tells me that most of the lithium in the world is lithium 7. And so when I say lithium has 3 protons plus 4 more neutrons adds up to 7, what I'm really doing is looking at the most common isotope of lithium, because that's the mass number that's closest to the average mass, the atomic mass. Okay, so this picture right here is the most common way that lithium looks in the world. I think that's it about isotopes.